Welcome to our video series about how to use Python at CCR. Python is a programming language used across many research domains. Since CCR manages a high-performance computing cluster, the way you would use Python on our systems differs from how you would use Python on your personal computer. This can lead to confusing errors. Here are some key differences to keep in mind when using the cluster. First, Python is installed on the cluster as a software module. You will need to load the Python module before doing anything Python-related. We have also installed some common Python packages as software modules. You will have to load these in order to use them. These packages may also be several versions behind the most up-to-date versions. You will not be able to use pip directly with the Python module. So, if you find directions about how to install a package online using pip, you may need to modify these instructions to use the package on the cluster. We do not support Conda at all. Trying to use Conda can mess up the configuration of your CCR account. Please do not use Conda on our systems. Finally, your compute jobs will have time limits. There is also a maximum amount of time you can request for a single job. You may have to design your Python scripts to account for this. With these in mind, I will now show you how to load the Python module. When you log into the cluster, you'll notice there is a version of Python already installed. Currently, this version is Python 3.10. This version will change as we update our systems. This version of Python is used for some compatibility reasons and should not be used in any of your workflows. If you install packages with it, they will fail when you run a job. If you build a Jupyter kernel with it, you will not be able to connect to the kernel. Do not use this Python version for any of your work. Instead, you will want to load the Python module before running any code. We can search for the Python module with the module spider command. We see there are a few versions, though you may see slightly different versions when you run this command. In this case, we want to load Python version 3.9. I can check how to load this module by searching for its specific version. Now we see that the Python module depends on the GCC core module. We can load both of these with the module load command. Notice how the version of Python has changed to match the module version. This means we have successfully loaded the Python module. Now that we have covered how to load the Python module, I will show you how to load package modules. CCR makes some frequently used Python packages available on the cluster as modules. You will be able to load these once you load the Python module. Since these modules are installed manually by system administrators, they tend to lag behind the most up-to-date versions online. If you need a newer package version, you will need to install it yourself. With the Python module loaded, we can now load any package modules we wish to use. As an example, let's load the matplotlib package. First, we will use module spider to find out how to load the package. We will check the specific version for any module dependencies. We load matplotlib with the module load command. Once loaded, we can import the matplotlib package from within Python. Some packages come installed as extensions within software bundles. As an example, the pandas package is available in the SciPy bundle module. I'll demonstrate what searching for one of these packages looks like. We module spider for pandas in the typical way. We see that it is blue and has a trailing E in the output. This means it is available as an extension. By looking for the specific version, we can see which module we need to load, as well as its dependencies. In this case, we will need to load SciPy bundle. Once loaded, we can import pandas within Python. As you use Python at CCR, you may find the pre-installed packages we offer do not suit all of your research needs. In this case, you will have to install software for yourself. There are a few methods you can use. In this video, we will focus on virtual environments, including how and when to use them. You can use virtual environments on the cluster in a similar fashion to your personal computer, with a few caveats. As we mentioned before, you will not be able to use Conda. Since Conda can mess up your account settings, do not use Conda to create virtual environments. Instead, you should use Python's built-in venv package. By using a virtual environment, you will be able to use pip to install new packages. However, there are two main cases where pip will fail to install packages correctly. Specifically, packages which rely on C libraries and packages that are GPU-enabled cannot be configured properly using pip. It may not always be clear when your package relies on specific C libraries, so you may run into confusing errors down the line when running your code. Furthermore, with packages like PyTorch or TensorFlow, you will not be able to configure the package to properly detect GPUs on the cluster. In either of these cases, you will need to use either EasyBuild or containers to install your software. Now that I have gone over the two cases in which you should not use virtual environments, I will now show you how you can create your own. Before you do anything with virtual environments, make sure you have the Python module loaded. Any environments built without the modularized Python will fail while running jobs. With the module loaded, you can run the following command. This uses the venv package bundled with Python to build an environment called myenv. Of course, you can name your environment however you like. Once built, we will have a directory called myenv where our virtual environment lives. We can activate the environment by sourcing its activation file. With the environment activated, we can install packages with pip. I will use the beautiful soup package as an example. We will use the typical pip command to install beautiful soup. Once installed, we can verify BS4 will load within Python. As a final note of caution, you may want to mix and match using pre-installed modules and packages you've installed inside virtual environments. While this is possible to do, we recommend you do so with caution. In some circumstances, everything will work fine. However, you may also run into dependency conflicts between the system modules and the packages you tried to install. It is not always easy to predict whether one of these version collisions will happen, so caution is needed. Once you have created a virtual environment, you may want to use this environment in an on-demand Jupyter session. To do this, you will have to build an interactive Python kernel using your virtual environment. Luckily, this is a pretty straightforward process, which I will demonstrate in this video. I will be using the myenv virtual environment I built earlier in this series. First, we always recommend you load the Python module before working with Python on the cluster. Now, we can activate the virtual environment I built previously. We will use pip to install the ipykernel package, which is used to build Jupyter kernels. Once installed, we can use the following command to create a new kernel. Please note, it is important to use the user flag to install the kernel in the correct location. As always, you can name your kernel however you'd like. With a kernel installed, we can go to an on-demand session to check if things are working properly. We'll open our Jupyter session and create a new notebook where we select our new Python kernel as our computational kernel. I had installed Beautiful Soup into this environment earlier, so let's see if we can still import this package. Since we don't see any errors connecting to the kernel or loading the package, this means our kernel has been installed correctly.